Okay, thanks, Caroline. Good afternoon, everyone, and hello to those of you who are watching this on TIA TV, otherwise known as YouTube. Michael just told me I'm now supposed to look and act like Madonna, so I don't think that's quite a very good analogy, but anyway. Can everyone hear me? Is that good? Not too loud? Very good. Okay. So my task today is to tell you about the purpose of this Viticulture project, which in the context of the SenseT program. It's one of the 5 practical projects. Richard Rawnsley is going to later talk about the Dairy and Beef project, and TIA is also involved with the Pathways to Market project led by Mark Tamplin. So this project we're now some 11 months into a 2-year project. And so what I want to do today is really focus on the why and the how of doing this work, because really the what is yet to come. And I also wanted to spend a little bit of time, this is the first time I've presented in this particular forum, so I also wanted to spend a bit of time looking at how we came to what we're going to do based on some of the thinking during the scoping phase of the project. And so I want to spend a little bit of time talking about the role of machines in the decision-making process, and then touch on the criteria for effective decision support. And then I'll get on to what we're doing with the initial R&D in vineyards, the many questions that we need to answer in this work, and also describe our participatory approach to co-innovation. So the SenseT program, SenseT is a big data project based in Tasmania. What this means is that it will no longer be necessary to recreate data sets every time we have a new question to ask or a problem to solve. So to put this in an agricultural context, many of us are involved with field work. We'll go and put an experiment down in an orchard, a paddock, a field, a vineyard block. Now, we can't put that experiment over the whole farm, so we select a proportion of an area that is representative of the whole farm, and then we put down an experiment that might be a small plot replicated trial, and then we have to choose a sample size. We can't go and measure every single plant to see how it's feeling, so we actually have to do some sort of sampling strategy. Now, the proponents of the big data will tell us that one day in the future we'll be so sensorised that instead of having a sample size, so if n equals the sample size, one day we'll be able to do experiments that involve n equals all. Now that's a big grand vision, but this is how the big data people talk. And I've already embarked on some of this myself with whole of block experimentation, where the whole process enables you to collect and deal with a lot of data and do some quite complex spatial geostatistics at greater resolution. So anyway, I just wanted to touch on that big data idea. This is a book that I've read. It's a very easy book to read. If you want to know more about that big data concept, it's quite a good, easy read. So, right. Okay. So, as I said, there were 5 practical projects, and basically the purpose of these are to act as use cases in the IT speak, to do the R&D to inform the developing SenseT architecture and the commercialisation. So these practical projects are firmly in the R&D realm, but there's a whole parallel pathway that's to do with commercialisation, and of course there'll be crossover bits of R&D going into the commercialisation phase as that goes along. But it's really about demonstrating what's possible with stakeholders and ultimately for their buy-in. So a basic premise of SenseT, one of them is this particular hypothesis, and that is that people who access tailored, timely and context context-specific information make better decisions. So I just wanted to explore that for a moment. So you're probably all aware of the rational decision-making process, where we use a logical process to gather all the information. We establish the different decision criteria, we weigh up all the different options, and we choose the best alternative, we implement the decision, and we evaluate it. And I think many scientists and professionals like to think that we follow a rational decision-making process. But we all know the senior executive who's got imperfect information and needs to make an urgent and important decision will revert to their gut feel and or their accumulated but tacit knowledge. Of course, in the real world, most of us rely on this form of decision making. Yes, certainly we do use our head and tools and logic and reasoning, but we also rely on our experience, our gut instinct, our heart, our emotions. And in the farming world, they also rely a lot on so-called rules of thumb. So to give you an example of that, for grape growers, they're coming up to the flowering period now. They know that the soil is full of moisture at the moment. The grapevines are going to grow very rapidly and vigorously. They know that if they have lots of cloudy, overcast days and the UV index is low, that these are conditions that are going to be very suitable for a disease called powdery mildew. So they know from their experience, and it's their rule of thumb, that under these conditions I need to make the decision to shorten my spray intervals to prevent powdery mildew from developing. So that's an example of a general rule of thumb. Now, what can happen though is we shouldn't discount these, because rules of thumb can actually emerge after people have been using a decision support tool for a while. By using the tool, there's learning that goes on, and they suddenly, in their own minds, they realise for their local situation that a certain amount of A relates to a certain amount of B, and they come up with their own rules of thumb. Another way of looking at decision making is the influence of the so-called inner circle. In this is work done by Tom Phillips in the 1980s, and he was referring to the family farmer. So if we consider the farmer to be that's the person in the centre, immediately around that farmer is their inner circle of, say, family members or those who would share in the consequence of any decisions being made. You can then imagine on the outer circle is all the information out there that is provided from what he calls the socially distant subject matter experts. And then in between is a circle of people who have a relationship, a trusted relationship with that farmer, a so-called trusted advisor who is there to help interpret and evaluate that particular information. So in a typical process is, the farmer goes out to get information, brings it back to the inner circle to discuss, goes out to get some more information, brings it back to discuss, realises they need to go to their trusted advisor to help interpret that information, and then goes back and makes a decision very much influenced by that support in the inner circle. And this is what a complex decision looks like. Phillips mapped every step of a farmer making a decision to build a new dairy. And so you can see there were multiple steps in that decision-making process. And the point here is that, yes, there were multiple trips out to get information. There were relatively few steps to go to the middle circle, the so-called evaluation circle, but they turned out to be critical in the final decision that was made by the farmer. It'd be interesting to know, what this map would look like in the age of the internet. So I guess, what does this bring us to? I guess a big question for me is, can machines take on more of the role of this middle circle? Namely the evaluation done by the trusted advisor. And I've since learned that there is a whole discipline around the concept of trust in the semantic web. So I think when we talk about enhanced decision making, I think what we really mean is helping people to search that growing body of information and then making some sense of it. And so I think Phillips then probably did some of the first sense-making research in Australian agriculture. And so this brings us to effective decision support. And I think it's important then for this to be effective that we need to understand the context in which decisions are being made. We need to know how to aid evaluation of information for discussion within that so-called inner circle. And indeed, some people refer to decision support tools as discussion support tools. I still like decision support tools as a terminology. I think discussion is one of the functions. And also from the agricultural extension literature, we know that there are certain criteria for adoption of any technology, and these include it needs to be usable. Is it easy for the farmer to use the information? Is it useful? Is it useful to the needs of the farmer? Is it accessible? Is the information accessible? And that's very important when we're talking about the internet. And quality. Is the information locally relevant, consistent and accurate enough for the job at hand? And when I really mean accurate enough, you know, we don't need accuracy just for the sake of accuracy. It's important to know what level of accuracy is needed. So with these concepts in mind, we embarked on this Viticulture project. And this is as I said, it's a 2-year project. It's being led by TR, and we're working very closely with our colleagues, ICT colleagues in CSIRO. Liliana Cabral is my equivalent in CSIRO. Through industry consultation, we decided to focus on developing tailored alerts for a disease known as Botrytis and frost, and also to develop some general situational awareness around environmental factors for grape growing. So frost injury is something that can occur. It's usually a springtime phenomenon as those young shoots are coming out. Hopefully we're over the period of the deep frost risk now that we're into late November. The other risk is bunch rot or grey mould. This disease happens later in the growing season as the grape berries are starting to ripen, although the infection can happen weeks or months beforehand. The level of this disease, whether or not it's an issue for grape growers, really depends on the wine style that's being produced. A little bit of botrytis can make a really nice wine, but if you've got a lot of mould, growers will be dumping mouldy bunches, putting them onto the ground. If they're making red wine, it'll strip the enzyme in the fungus, it'll strip the colour out of reds. The winemakers have to spend a lot of money to remediate the effect of this mould, of using mouldy grapes. It's not really possible yet to predict whether frost injury will occur or not. There are many conditions that can come together to determine whether or not you get damage or not. But we can certainly look at the conditions around a particular frost event. And this just shows one that we monitored recently, where you can see the temperature going down below zero for a certain amount of time in the evening. So the sort of decisions growers are making are, if they reach a particular, they'll decide on a threshold air temperature, at which point they'll go out and prime the pumps. Often the frost mitigation is the use of overhead sprinklers, and they'll switch them on, and then they'll have to make a decision about when they're going to switch the gear off, and they also need to decide where in the vineyard they're going to implement the frost mitigation if they're using. And then later on, coming back and looking at the data and, you know, how deep was that? Did we get injury? So we actually need to start collecting a lot of data to actually understand all the elements that will lead to frost injury, as well as the atmospheric conditions. That just shows what we saw recently with frost injury. You see these nice little green buds coming out, and then cold temperatures, and they don't like it at all. With botrytis, again, the growers know intuitively what conditions during the ripening period are conducive to this disease. But But what we've done with our previous TR research is study, I think we studied at least 40 Botrytis epidemics, and we looked at all the weather variables and monitored the epidemics very closely to then relate what conditions were related to a certain severity of Botrytis at harvest. So we've come up with two models. I'm not going to go into detail of them. An early season model which gives the growers enough time they get through the flowering period and they can see how much potential disease has been set up in the crop, and then given that risk level they can then decide, well, I need to do more or less in terms of Botrytis management from this point onwards. Then when they get towards the end of the growing season and the disease starts to appear, they can make decisions. The sort of decision making then is around, it's a daily to weekly decision around, is this disease going to get worse? Should I harvest the crop early? Have I got information to negotiate with the winemaker to get the crop off early, because that winemaker will be wanting those grapes to stay on as long as possible to get the sugar and the flavour and so on. But for a vineyard manager, getting that crop off can be really important, because next week the crop may not be there because it might be totally mouldy. So already, just to show you what is there already, there are a number of proprietary solutions out there already where you can buy a weather station. There'll be telemetry in a database, there'll be data analysis, and you can get electronic delivery of information, and this just shows a particular company that's putting out various risk indices or weather variables. An issue with some of these is they're more situational awareness. They're not actually predicting risk per se, and it's a very difficult thing. It must be very difficult for a vineyard owner, manager to decide, well, which gear am I going to buy? This one will do these functions. Another bit of gear over here will do this. This one will do soils, and this one. So there's a whole lot of proprietary solutions delivering one or two things, but that's sort of not all together in one particular package. So this is where SenseT comes in terms of the data collection and management to start with. You can imagine if we've got all different makes and models of sensors out there, some might be going into a Bureau of Meteorology database, that's your proprietary one. What's happening is that data, to get that data to integrate the data, it has to be put into a common standard format, and once it's in a standard format, the content of that data can be described. And this is when we get federated data. And when you get that integration of data, that data can then be used for multiple purposes. And so it's about a whole lot of integrating all this into a single architecture. And then the SenseT architecture is something like this. Here's your processing and storage. There's then a layer that's involved in analytics, different types, real-time. So the CSRO IT leader I work with, her expertise is semantics, and she's involved in annotating data and describing it. And then from there you can get some services developed, so-called application program interfaces, and then someone commercially can come into that platform and develop whatever app they like. And I think most of you here are familiar with apps and iPhones and all that sort of thing. So our initial R&D then is about building some of these components in a R&D setting, not the commercial eventual setting, but the user interface, and that's what the user sees, is about dealing with historical data, real or near-time situation, also future conditions and scenarios. Caroline, you'll let me know when I need to finish. At the moment, we are, the first step, of course, is collecting the data, and we're currently deploying sensors in 4 vineyards, and that's supplying data to the developing SenseT infrastructure. At each vineyard, we have a so-called gold standard automatic weather station for research purposes. We want to make sure we're getting really good, high-quality data. So this is our standard, it's collecting the full range of weather variables, and then we have a set of substations which are just collecting a subset of variables that relate to the variables we need for Botrytis decision support, and that's surface wetness, humidity, and basically temperature and surface wetness duration. We've made a conscious decision to site our gear outside of vineyard blocks because our models are calibrated to having the sensors in a grassy area outside the vineyard block. There's a whole lot of arguments. You can talk forever about putting sensors within vineyard rows, but there's a lot of, as you know, there's a lot of within field variation, and you have to decide where you're going to put gear. Obviously, if it was highly sensorised, then you probably could put lots of sensors right through, but this is what we have for the moment. There are many questions to answer as we do this work. Naturally, we're constantly asking, what do the end users require for usability and usefulness? How can we use knowledge to discover appropriate third-party sensor data? How sensitive are our risk models to changes in environmental conditions and sensor proximity? We have a couple of statisticians at CSIRO doing some work around this. And, you know, there's this whole question around sensor density and how many, where do you need them for a particular question? And for frost, it might be quite different than something like Botrytis. Botrytis, we might just need one on-site weather station. For frost, we might need much, you know, a higher density to get all those little nuances that happen within the field. We want to know, you know, what commercial grade sensors can be used as opposed to very expensive Campbell Scientific gear. And then ultimately, when we've done the work, how did access to better information influence decisions, plus many, many more. I'm now getting on to a bit more of the how we're doing this work. And to answer those questions about usability and usefulness, we're working with industry. Industry are actually we actually consider them part of our project. We recently conducted a user requirements workshop involving the members of the Wine Tasmania Technical Committee, our grower cooperators, and we went through a facilitated process to ask them, well, what are your most important decisions in the vineyard, and what information do you need to support those decisions? We then got them in little groups, and they had butcher's paper and coloured pens and crayons, and they had a great, lovely time coming up with their ideal solution. We said, this is Sense T, this is what's possible. Tell us what you would like, how you would like to receive it. And we just got this wonderfully rich set of ideas of, they drew here. Here's an iPhone app that's got all the different risk states and a slide ruler. So we're getting really good. So they can tell their risk states, and then they can dig deeper to find out what's underlying that. So it was a really valuable thing to do. And they gave us suggestions again for how they want to interact with this thing. Little things like the ability to work offline in case they've got coverage issues, and opting in and out of particular information. They don't want to be overloaded with information. Another interesting one was the need for a community discussion space, and this is things like, one vineyard manager putting an image up and saying, look, I've got powdery mildew down in Block B. I'm not going to tell you how much powdery mildew I've got because my grape buyer might be watching, but I'm letting you guys know this disease is active in our region at the moment. And so they felt that this was also, they needed a platform to be able to share their observations, so there, the ability to put data in as well as the ability to get information out. And I've just put this, tried to put how this is all working into one diagram to show that when we're involved in developing technology, services, products, it's just a reminder that you don't do the research in isolation, that you need to involve many different people to make this sort of work happen. It starts off with your needs and stakeholder analysis, being participatory in the design process, having these people intimately involved in the so-called user-centred design and the participatory R&D. And they're also, as a researcher, you can't get away from being involved in targeted communications when you work in these big programs. We all have to do this, because if we tell our credible stories, of course, then we get a bigger circle of influence. And we're also intimately involved in evaluation activities. You've heard me talk about monitoring and evaluation. And Michelle Buntain, who's working on this project, she's been out with our grower cooperators doing semi-structured interviews with them to get some baseline data, and then she'll interview them again at the end of the project, and then we'll get some good... and this is where the co-learning happens. We hope for better outcomes and a useful and usable system that's also scalable. This is just to show you, it's not all the people involved, but are some of them. Amanda and John from the Sensitive program. John's here, and Libby's here, who's also doing a lot of work. And Liliana, who's the leader of the ICT research. We've got statisticians and software engineers, and as I said, our great grower cooperators are actually part of our work. So with that, I'd just like to leave you with two ideas, and that is that farmers are intuitive thinkers, but we think data analytics can help. And the other one is that early stakeholder engagement ensures better outcomes. So I'll leave it at that. Thank you.
Thank you.